Hello everyone. Today we will be looking at the concept of internal resistance. So don't forget to like and subscribe to Driven Math and Physics. Truly appreciate the support. Now, when we're talking about internal resistance, we're talking about the resistance found in a cell or a battery. What you have to understand is a cell and a battery actually has voltage, and this voltage is able to create a flow of current when connected in a circuit. Okay, but the same cell actually has, because of the material that make up the inside of the cell, it actually has a resistance as well, a level of resistance, and this resistance opposes the very current that the cell is producing. So it can't help it because it comes from the material that makes up the inside of the cell. So every material, the same way that we say even connecting wires, ammeters and voltmeters, all of them have resistance, but the resistance in some of the components is negligible. That's why we don't really consider it. And the same way with the cell has a small amount of resistance called internal resistance because of the material that makes up the inside of the cell. And so that's where it comes from. That's why it's called internal resistance. But now the resistance that is found across the other parts of the circuit, that one is called external resistance. But the resistance inside the cell is called internal resistance. So the way it's defined is that this is the resistance, or maybe resistance or opposition to the flow of current. So resistance of a cell to the current it produces. So this is the resistance of a cell to the current it produces. The cell produces a current, but because of the material that makes up the inside, it also opposes the same current to a certain level. It's just a small amount of resistance. How do you observe this? Okay, first of all, if we're going to understand, maybe realize where we can see this, is maybe let's understand first of all the concept of EMF. Okay, EMF is electromotive force. Okay, EMF is electromotive force. It's not a force, it's simply voltage. Okay, so EMF is the maximum amount of voltage a cell can supply. So this is the maximum amount of voltage a cell or a battery can supply. That's the EMF, electromotive force. Is maximum amount of voltage a cell can supply. How do you know the EMF of a cell or a battery? Okay, it's easy. Every battery or cell, when you buy it, especially, do you remember the cells that are used for remote controls, maybe for a TV screen or anything like that? You will notice that most of them are 1.5 volts. Okay, they're 1.5 volts, and this is labeled on the cell, and this label is what we call the EMF. So on the cell, they will label the EMF, meaning they will label the maximum amount of voltage that cell can supply. Okay, if you have two of them, it means it will be 3 volts. Okay, so that's what you have to understand. So what for the remote control, it can be 1.5, but those ones, the big ones, what do you call them? Just forgotten the name, but yeah, the ones which you can use in a torch, like that, things, the medium sized ones. Okay, those ones are 1.5 volts, and the label on them is actually what is called the EMF, the maximum amount of voltage those cells or batteries can supply. Okay, so what you will notice is that take for instance, if a 1.5 cell is connected in a circuit, okay, and then you connect everything and current begins to flow. Before current begins to flow, if you connect a voltmeter across that cell, okay, you'll get a reading of 1.5 because that is its EMF. Okay, if you connect a voltmeter across a cell, you'll get a 1.5 reading. All right, but when the circuit is complete and current begins to flow, okay, current begins begins to flow. When current begins to flow, okay, and you take a voltmeter and you try to read the voltage across that cell again, you will not find that it's 1.5 again. Okay, you find a lower value. The reason for that is that as the current begins to flow, there will be a resistance to the flow of the current. This resistance causes the cell to lose some energy. Remember, voltage is simply joules per coulomb, meaning amount of energy on every charge. Okay, that means as the current begins to be supplied, or maybe begins to flow in the circuit, as voltage is being supplied to the circuit, what you'll notice is that there is a drop in the EMF. So EMF may be 1.5, but as the current begins to flow, you may find that a value of voltage of 1.2 volts is read on the cell. The reason for this is because of the internal resistance in the cell, there will be a resistance to the flow of the current. And this resistance to the flow of the current leads to a loss in voltage, or maybe a loss in energy. This is why the voltage that you begin to read when current begins to flow is 1.2. Okay, because there will be a voltage drop or an energy drop as the current begins to flow. This is caused by the internal resistance of the cell. You observe this whenever you're dealing with circuits. Try it at your own time. Okay, read the voltage across a cell before you connect it in the circuit, and then try to connect and form a complete circuit, and try to read it again. You'll notice that there is a difference in the values, and that difference is coming about because of the internal resistance of the cell. Okay, this is where the concept of internal resistance is important. Now, let's try to build this up. Okay, let's try to see if maybe we can build this up properly. Okay, I hope this is making sense to you. That's internal resistance. Now, pay attention. Okay, so the maximum amount of voltage across a cell, this is max voltage. Okay, and this is obtained before current flow. Okay, and then there's another voltage that you begin to read when current begins to flow. That one is lower than the EMF. This is because of the internal resistance. That amount of voltage is called terminal voltage. So this is after current flow. Okay, this begins to happen when current begins to flow. This is terminal voltage, but I told you that there's a difference here. Okay, the EMF is higher, this one is low. Okay, the reason why it's low is because of the internal resistance. All right, so this causes the charges to lose energy, and hence there is a voltage drop as the current begins to flow. Okay, there's a difference in voltage. Now that means we lose some voltage. Okay, this voltage we lose due to the internal resistance is actually called lost voltage. Okay, lost voltage. This voltage is the one we lose, but when we move from EMF to terminal voltage, we lose energy there. That lost voltage is what we call lost voltage. Okay, that's what I want you to understand. Now, if we can try to put this in a formula, we can say it like this. Okay, if we try to say EMF minus terminal voltage should give you lost voltage. Is this fair to say? Okay, EMF is the maximum value. Terminal voltage begins to be seen when current begins to flow. It's a lower value. If you subtract the two, it will give you the voltage that we have lost between EMF and current flowing. Does that make sense? Okay, so we'll write it properly and say lost voltage is equal to EMF minus terminal voltage. Okay, now I want you to understand something. There are symbols for this. Let's put a symbol for EMF as E. For terminal voltage, it will be V as voltage. Okay, for lost voltage, okay, for lost voltage, it will be V lost. Okay, V lost. Now, for internal resistance, the symbol is always small letter r. And for external Remember I told you about external resistance? The resistance in the rest of the circuit, not in the cell, but rest of the circuit. External resistance, you remember, is still capital letter R. Okay, those are the symbols that we're going to use. Okay, so it means here it will be V lost equals E minus V. Okay, that's terminal voltage. All right, are you here? I want you to understand. Are you here? Okay, so let's try to move on from this. Let's try to break this down and make sense of it properly. Now, let's write terminal voltage here. To find terminal voltage, we already know how to do this from Ohm's law. We say that it's the current flowing in the circuit times the external resistance, because the terminal voltage is the voltage that begins to flow as current begins to flow. Okay, and that voltage is flowing in the rest of the circuit, not inside the cell, but the rest of the circuit. That voltage will meet the external resistance. That's why it's I times capital letter R. Okay, so that's what we know about the terminal voltage. Okay, now let's talk about lost voltage. Okay, lost voltage happens due to the internal resistance. The current is the same, okay, but the resistance is the internal resistance causing the lost voltage to happen. So the formula for lost voltage will be R times I times small letter r. Okay, that will give you the lost voltage. Does that make sense? I think it does. Okay, so let's substitute everything in there. Voltage lost will be I times small letter r equals E minus the terminal voltage will be I times R. Okay, can you see that? This is very important. Okay, this is very important. Now, if we had to write and make E subject to formula, E will be equal to I R plus I R. Okay, or I R plus I R. It's just the same thing. Okay. From there, we can factor out I because it's the same, so it will be R plus. Oh, sorry about this. Okay, so it will be R plus small letter r. That should give you the EMF. Okay, that's the formula.